So once again, I welcome all. In last lesson, we discussed the geometric meaning only for first degree polynomials or linear polynomials. And today we'll discuss for higher degree polynomials, the geometric meaning of zeros. Okay. So we start with the quadratic polynomial. Quadratic polynomial or second degree polynomial. A second degree polynomials means quadratic polynomial, and the general form of a second degree polynomial or quadratic polynomial is p of x is equal to ax square plus bx plus c. Okay, you know the general form. P of x is equal to ax square plus bx plus c, and a cannot be 0. If a is equal to 0, then what will happen? Then it can be a second degree. The first term will become 0. Okay, so a cannot be 0. B can be 0, no problem. Okay, so ax square plus bx plus c is the general form of a second degree polynomial. And here a, b, c are constant and x is the variable. And a, b, c are called the coefficients. A is called the coefficient of x square term, and b is the coefficient of x, and c is the coefficient of x raised to 0. That is, x raised to 0 is 1. Or in another way, you can say the constant term is c. Okay, so we will start with an example. In last lesson, we have discussed the two examples for linear polynomials, and we have drawn the graphs of those polynomials, and we have seen that the x-coordinate of the intersecting point of the graph and the x-axis is the 0 of the linear polynomial. Okay, and today also we will start with the example, and I choose one polynomial like this. P of x is equal to x square minus 2x minus 3. So we will draw the graph of y is equal to x square minus 2x minus 3. We will see how the graph looks like and the relation between the zeros. Okay, so we want to get the coordinate points. Okay, I take x values minus 2, then minus 1, then 0, then 1, then 2, and then 3, 2. Okay, now you have to find the corresponding y values. You do yourself. I think you can do this in your mind. Y, what is y? Y is x square minus 2x minus 3. What will be the value of y if x is equal to minus 2? What will be the value of y if x is equal to minus 1? So I will check it here. Our polynomial is p of x is equal to x square minus 2x minus 3. And what about p of minus 2? P of minus 2, we want to find the y value. We will get by substituting minus 2 for x. That's p of minus 2. That's y in the first box. Yeah, so minus 2 square is 4, right? Then minus 2 into minus 2. Minus 2 into minus 2 will become minus 4. Already one minus is here, so it will become plus 4. Okay, so 4 plus 4, then minus 3. So what will be the answer? 4 plus 4 is 8, then 8 minus
5.
3 is 5. So 5 is the answer. So if you find all the values, you will get a table like this. So when x is equal to minus 2, y is equal to 5. When x is equal to minus 1, x is equal to 0. So this will give you a set of coordinate points on the plane. So if you join all these points, you will get the graph of p of x. And in last lesson, we took only 2 pairs of points, but here we took many pairs. The reason is we know the linear polynomials are a line graph. Yeah, for any linear equation, if you draw the graph will be a line, a straight line. And to draw a straight line, 2 points are enough. If you get 2 points, you can join those points, you will get a straight line. But for polynomials of higher degrees, the graph may not be a straight line, can't be a straight line. For second degree polynomial, we will see how the graph looks like. To draw the graph, we need more points. So I took only 7 pairs of points, x coordinate and y coordinate. So you can mark these points on the plane, then we'll get the graph of this polynomial. Okay, so I have opened whiteboard, and here we want to mark these all points. Okay, so these all points we want to join. Okay, the graph will looks like this. If you find some more points, this graph will continue like this to infinity. Okay, so this is the graph of p of x is equal to x square minus 2x minus 3. So for this graph, if you get only 2 points, we cannot draw. That's why I calculated a set of values, 7 or 8 enough. Okay, so we got a curve like this. This is the graph of second degree polynomial. For any polynomial of second degree, if you find the graph, it will be like this, or sometimes it may be open to downwards. The graph will be like that. And there is a name for such graphs. The name is parabola. Parabola, you may have heard parabola. If you get a chance to study BSc mathematics or in some other higher studies, we will study more about parabola, this shape. Okay, so we only need to know a second degree polynomial looks like a parabola, and the graph looks like a parabola. Okay, so come back to our presentation. Okay, so what we have seen now? We have seen that the x square minus 2x minus 3, we drew the graph. So here you can see this graph touches the x-axis at 2 points. This graph touches the x-axis at 2 points. Okay, the 1 point is here at -1. The coordinates of this point is -1, 0. Coordinate of this intersecting point is -1, 0, and one more point is here, 3, 0. The second point where the graph intersect x-axis is 3, 0. Okay, you take the x coordinate of this intersecting point, that is -1 and 3, and they are the zeros of given polynomial. The same idea as in the linear polynomial. In linear polynomial, we have concluded from the example that the zeros are the x coordinate of the intersecting points of the line and the x-axis. The same idea here. Here also the x coordinate of the intersecting point of the graph and the x-axis will be the zeros of the given polynomial. You can understand this from the table. If x is equal to -1, if x is equal to -1, the corresponding y value, that's the p of x, the value of p of x is 0. From the table itself, you can understand that -1 is a 0. If x is equal to -1, the y value or the p of x value is 0. That's the idea of 0, right? So you have studied that for a p of x, a value k is said to be a 0 of p of x if p of k is equal to 0. Okay, so here p of -1 is equal to 0. So -1 is a 0 of this polynomial. And again, 3 is also a 0 of this polynomial. Thus p of 3 is 0. From the table we understand, also from the graph we get the idea. Okay, here the graph also intersects the x-axis at 3, 0. The x coordinate is 3. So the x coordinates of the intersecting points are -1, 3. So these are the zeros of given polynomial. Okay, so I hope you got the idea how to the relation of zeros of a second degree polynomial, quadratic polynomial. I'll show you one more example. We won't calculate the pairs of points. It's already there in textbook. I'll simply show the graph. Okay, this is I have taken the screenshot from textbook. This is already there in textbook. So the graph is p of x is equal to x square minus 3x minus 4. So if you find a set of coordinate points, if you mark the points on the plane, if you join these points, you will get a curve like this. You will get a curve like this, and this curve intersect the x-axis at -1, 0, -1, 0, and 4, 0. So which are the zeros of this polynomial? Which are the zeros of this polynomial?
-1 and 4.
-1 and 4. Very good. -1 and 4 are the zeros of this polynomial. Okay. So from this graph also, we confirm the idea that the zeros of a second degree polynomial or a quadratic polynomial are the x-coordinate of the intersecting points of the graph and the x-axis. Okay.